Right, guys, so I'm going to do a few problems for your review so you can see how this is done. Now, specifically number one, I couldn't remember how to do it, but then I remember, so I looked at my notes. Okay, so number one, the first thing you have to realize is that you have this formula that says that if the derivative of the inverse is going to, let's say if g of x is the inverse, okay, then the derivative of that inverse is 1 over the original function. And inside this function is going to be some number that's going to be the y-coordinate. Is going to be the y-coordinate of the inverse. Okay, so the first thing that I forgot to do when I was doing this the first time is that, and I think the formula is actually this, by the way. This is g of b and a, which doesn't really matter for you, but here's how it works. So the first thing you have to do is you have to find on the original function, this is the f of x function, alright? And this point right here, which I know is g prime, but g prime and g, the x's are the same, alright? These values are going to be the same. So on this graph, the y value is equal to 0, meaning you have to set this equal to 0, alright, and then solve. Now once you solve, and I would probably recommend using a calculator in this to solve this. Once you solve, you get that the answer would be, that happens at x is equal to 3. Alright, so that's the value that we're going to use. So now we know that when we take the derivative of this function, alright, when we take the derivative of this function, all we have to do is plug in that 3 into the derivative of f prime, to the derivative of f of x, and we'll get the answer. So the derivative of f of x is this. Which then will give you, let's see, f of 3. So again, I'm plugging in that 3 into it. Alright, so this is going to be equal to, and again, obviously you can use a calculator on this also. Blah blah blah, the answer is 10. Alright, so the formula says that g prime of 0 is the same thing as 1 over the derivative of function f at 3, which means that g prime of 0 is equal to 1 over 10. Okay, so that's the answer for that. Let's go through a few more. I think I did number 2 for most every class, but if you weren't here on that day, on Thursday, ask somebody to see their answer. I can do number 3 when I come back. See, I believe I did number 4 for most everybody. Alright, number 6, let me see. I'm trying to see what's the most beneficial for you. Now, I cannot remember how many classes I did number 6 with, so I'm going to do number 6. And if you already have this, then just fast forward. Okay, so remember, they're asking you, this means the second derivative of y. So you're taking 2 derivatives of this. So the first derivative, dy dx, is equal to, remember that the derivative of the natural log, alright, derivative of natural log is 1 over whatever is inside this natural log times the derivative of this. The derivative of 3x plus 5 is just 3. Alright, so this is going to be equal to 3 over 3x plus 5. Now you have to take another derivative, okay? So if you wanted to, you can use the quotient rule. But if you don't want to use the quotient rule, and I don't at this moment, I'm actually going to rewrite this like this. And then I'm going to use the chain rule because I think that's faster. Okay, so the second derivative of y, the second derivative of y with respect to x is equal to, let's see, and again I'm using the chain rule here, so I have negative 1 times 3, negative 3, 3x plus 5, subtract 1 from here, so that's negative 2 times the derivative of 3x plus 5, which is just 3 again. Alright, so one more time, I'd use the chain rule, so I have the outside being this negative 1, this function to the negative 1 power, so I multiply this times 3, and then subtract 1 from here, hence I'm taking the derivative, and then times the derivative of the inside. Derivative of the inside is just 3. So this is going to be equal to negative 9, 3x plus 5 to the negative 2 power, and you don't have that on here, so what I'm going to do now is I'm going to bring this 3x plus 5 squared to the bottom, and that is it. So I guess the answer is D. Alright, so that one, if you see something like that, it shouldn't be terribly hard for you, but we'll see. Alright, let's see here. I think I did number 9 and 10 with most of you, and if I didn't, you can just ask me when I come back, but there are some classes that I did this with, some classes I didn't, so I don't know. Let's go to the second review now. Now in the second review, let's do number 2. Now number 1 is pretty simple. Remember, number 1, anytime you're trying to find the limit, the first thing you should do is just plug the number in, and if you do, that one actually works. Alright, so on this one, we're going to take the derivative. Differentiate means to take the derivative of this function. Now, please notice that you have, you have a quotient rule here. You have a fraction, you have a rational function, which means you have a quotient rule. You're going to use the quotient rule. So, this is going to be y prime is equal to, let's see, low, right? And believe it or not, I still do it like that. Low d high minus high d low. So we have low times the derivative of 1 plus cosine. Derivative of 1 plus cosine is just going to be negative sine. Minus high, which is 1 plus cosine x, times the derivative of negative cosine. 1 minus cosine, which is just going to be positive sine x. That's positive sine x because the derivative of cosine is negative sine, but negative times the negative makes this a positive. So in this one, you just have to be real careful. Just don't make a mistake on this. It can be easy to make. Alright, the next part now is I have to multiply everything together. So I'm going to multiply this stuff and that stuff, and then add like terms if I can. So now I have, let's see, negative sine x plus cosine x sine x, and again that's just this part right here. Basically all I've done is distribute this negative sine x to those two numbers, and then now I have minus. Now notice that this minus is going to make that negative and it's going to make that negative. Alright, only those two. But if you don't want to make any mistakes, maybe we should do it like this, and then we'll worry about this later. Let's see, that would be minus sine x plus cosine x sine x all over, and I just noticed I forgot to square this right here, so square that, and then all over 1 minus cosine x squared. Alright, so notice that right here, this negative, I'll rewrite it one more time. This negative right here is going to make this sign negative, but it's also going to make this quantity over here negative. Now notice that this right here and this is going to add up to 0. And then you have negative sine x minus sine x makes that a negative 2 sine x. So the answer is going to be D. Okay, now let's go to a different page here. Remember on this one right here, I want you to take two derivatives. Take two derivatives, and remember that the second derivative tells you the concavity. If the second derivative, when you find your 0, okay, whenever you find your 0, if the second derivative is positive, it's concave up. If the second derivative is negative, then it's concave down. So remember that. Alright, so let's go to the next page here. Let's see which one do I want to do. I am not going to do number 4. I think I've done it for some people, but I will at least rewrite this for you. F of x is equal to, you have to look at it like this. Alright, so on this one, you have a chain rule, but you also have, once you take the derivative of sine 4x, you have another chain rule in there. So be careful, right? So try to do this one. Again, is a chain rule. Alright, now, on the number 5, alright, it says the function f whose graph consists of two line segments is shown below. Which of the following are true for f on the open interval a through b? So this is function f, and notice that it looks like an absolute value function. Alright, so it says the domain of the derivative of f is an open interval a and b. Alright, so the domain of the derivative is an open interval between a and b. What that means is that it's trying to tell you that it's continuous, that the derivative of this function is continuous. And it is not, because you know that at this point right here, at this point, what's the derivative of that point? The derivative is undefined. Alright, so the domain of the derivative is not defined at c. C is not defined here. So on the derivative, not this one, on the derivative of this function. So number 1 cannot be. Okay? And now, actually I'm going to leave it at that. Okay, so I eliminated one for you. Look through the other two and see if you can come up with the answer. If you don't, then talk to me Tuesday. Alright. Let's look at number 6. Now, on number 6, I know it's been a while since we've done this, but the first thing you can always do is plug in 0 for h and see what you get. So if you plug in a 0 here, that's just going to give you cosine of pi over 2. And cosine of pi over 2 is 0, but let's say that you don't know that. You had cosine of pi over 2 minus cosine of pi over 2, so that's going to be 0 nonetheless. And this is going to be 0. Now, because of this, remember I have 0 over 0, I can use L'Hopital's rule. Alright, so I can use L'Hopital's rule on this. So I'm going to take the derivative. So let me rewrite the limit as h goes to 0. Alright, so if I take the derivative of h, that is 0. Okay, so, no, sorry, the derivative of h is 1, so that's gone. So let me at least maybe write that. The derivative of cosine pi over 2 plus h, we're going to have a chain rule here. So we have the derivative of cosine is negative sine of pi over 2 plus h times the derivative of the inside. Derivative of the inside would, in this case, would just be h. Remember, pi over 2 is a constant, so the derivative of h is just 1. So this is it right here. And then from there, I can actually plug in 0 for my limit. So all I have is negative sine of pi over 2 plus 0. So that's not going to do anything. So I just have negative sine of pi over 2. Now the sign of pi over 2 is positive 1, which means that the negative sign of pi over 2 is negative 1. So again, hopefully you know that this is just negative 1. Alright, so make sure you polish up on your trig. So that one's that. Let's look at a few more here. Okay, now this is the slope of a tangent. The slope of a tangent to the curve, alright? So let me see if I want to cover this one or not. Okay, let's quickly cover this one now. The slope of the tangent to the curve. So what we're going to do here, we want to find the slope of the tangent to the curve, this thing, alright? Whatever you want to call this. So please notice that I have to take a derivative, right? To find the slope, I have to take the derivative. So what I'm going to do here is I'm going to take the derivative with respect to x. Alright, so this is, I can't even remember the name of this right now. But you have, notice that you have right here, you have a product rule, followed by another product rule. Alright, so this one is not difficult, but it can get really messy, so be careful. So we have the derivative of the first, which is 3y squared dy dx. Okay. Times the second, which is just x. And again, I'm only doing the derivative of this right now. Just this. Not that. I'm going to leave that for later. Alright, so this right here, the derivative of this is 3y squared dy dx times x plus the derivative of x. The derivative of x is just 1 times y cubed. Plus, well, and now I'm done with the derivative of this. Okay, so I'm finished with the derivative of that. Notice again I did a product rule. So now I'm about to do another product rule right here. So I have the derivative of y squared, which is 2y dy dx times x squared plus the derivative of x squared, which is 2x times y squared. And that is equal to the derivative of 6. Remember, the derivative of any constant is 0. So if you remember from stuff that we've done in the past, what we're going to try to do now is we're going to try to add or subtract all the terms that do not have a dy dx with it. So we're going to subtract y cubed and 2x y squared. We're going to subtract that also. So we have on this side, okay, let me write it one step at a time here, guys. Excuse me. So we have 3xy squared plus oh wait, I'm writing my dy dx terms here. I just rearranged this, by the way. I just put the x over here instead. And now I have this one right here plus 2x squared y dy dx and that's going to be equal to negative y cubed minus 2xy squared. Now if you remember, the next step would be to take to factor out dy dx and to have 3x y squared plus 2x squared y, and that's going to be equal still to the same thing. And then the final step would be to divide both sides by 3x. Well, not the final step in this case, but divide this by that and divide this by this quantity, and then now you have what you need. So now to figure out the slope at this point right here, all you have to do is plug in 2 for x and 1 for y into that, and when you do, you're gonna get this. Alright, by the way, number 9, remind me to do it, but basically this is gonna help you. The way to do this is to take two derivatives. All right, so remember that the first derivative is just going to tell you max or mins, possibly. All right, and your second derivative, though, is going to tell you if you have your point of inflection. All right, so the second derivative, if you set that equal to 0, that's going to give you the points of inflection. So see if we can do that. But if not, then I can talk about it on Tuesday. All right, 11. That'll be the last one I'll do. Then from there on, you can just try to do the rest as best as you can. All right. So in this one right here, now you can do it many other ways, but number 11, what I'm going to do here is it wants to know. Okay, so it wants to know where the relative maximum is at. All right. So the first thing we have to do is we have to take the derivative of this, which would be 2x minus 3x squared. Alright, so we have to figure out my max or min, I need to set this equal to 0. Right, and then now we're going to have, let's see, we're going to factor out a x, so we have 2 minus 3x is equal to 0, so we have a horizontal tangent at 0, and we have another one at, let's see, 2/3. Okay, so we have that. Now, none of those answers say 2/3, so it's probably going to be 0, but let me see, making sure I didn't do anything wrong. It doesn't, oh wait, I did do something wrong. That's going to be 6. And that's probably going to change my answer quite a bit. Yeah, so let me erase this. My apologies. Hopefully that's not too annoying. Alright, so we're going to factor out a 3x now. So this is going to be 2 minus x is equal to 0. So one answer should be x is equal to 0. Remember, if I said 3x is equal to 0, that's what I'll get. And then get x is equal to 2. So really the question is, are both of these a maximum, or is one a minimum, one a maximum, right? So in order to check that, well, you can do sign analysis if you want. Remember that all you have to do is draw yourself a line. There's 0, I guess there's 2, and then plug in points to the left and right until you find it. Okay, you can also take the second derivative, but you're still going to have to do sign analysis anyway. So again, do sign analysis on this, meaning plug in a point to the left and to the right, okay, of the derivative, and then figure out if that's going to be a maximum or a minimum, and that should give you your answer. Alright, well, let me see if I got anything else to say about this. Alright, I don't, so I'm going to go ahead and stop here. Hopefully that'll get you started, but remember, you guys have to work through this. I forgot to tell you, I'm not going to have any corrections on this next test. Alright, so on this test that's coming up on Wednesday, there will be no corrections or making up of points or nothing like that. Alright, so try to do your best on Wednesday. Alright, that's the only chance you're going to get.